My name is INV Suyranarayana. I am a full stack trainer in skill development department in IARE, Dundigal, Hyderabad. Today, I am going to teach you arrays topic in Core Java. Arrays topic in Core Java. This is our agenda. Arrays topic in Core Java. This is our agenda. In this agenda, we want to cover single dimensional array, one dimensional array, two dimensional array, and three dimensional array. So after understanding after understanding 2 and 3 dimensional arrays, I hope the students will be able to even implement 4, 5 and n dimensional number of arrays also. Depends on the project requirement. Sometimes more than 3 dimensional array of data may also be need to be maintained. Mostly 2 dimensional, 1 and 2 dimensional are very often, 3 dimensional occasional, and sometimes the extreme may go to 4th and 5th dimensional array. But anyway, after understanding 3 dimensional array, I am very much sure that you will get an idea on a confidence on implementing 4th and 5th dimensional array also. Let us start with the session. Why array? Why array? In simple terms, array is a collection of variables of the same type or homogeneous type. So, for example, I want to declare some 10 integer variables. How could I declare 10 integer variables? Int I1, I2, I3, I4, I5, I6, I7, I8, I9, I10. Instead of declaring 10 variables, so the length of the variable declaration increases. Fine, this is fine. For example, if I want to declare 10 student IDs or 50 student IDs or 100 student IDs at a time, if I want to declare. So in one row, you declare 10 variables. You repeat these 10 variable declarations for 10 more times to declare 100 variables. So almost 10 full lines of each line contains 10 variables of such a wider and longer space is required in the programming. And the lines of code in the programming will increase to declare 100 student IDs. Similarly, whenever we want to store the marks of a student, say for example, English, Social Science, Hindi, Telugu, Maths. For example, if we want to store 6 student marks, so we need to declare int mark 1, mark 2, mark 3, mark 4, mark 5, mark 6. Instead of declaring 6 integer variables, you simply declare only simple integer array. Int marks square bracket is equal to new int of 6. 6 integer variables will be declared. You can happily store 6 marks. Similarly, if you want to declare, if you want to store 100 student IDs, so student IDs square bracket is equal to new int of 100. Finish. 100 integer variables are declared. Similarly, 100 student email IDs or 100 student mobile numbers. Today we are having beautiful topic introduced in every modern programming language called data structures. Like say for example vector, hash table, properties, list, set, map. So many advanced data structure concepts are introduced in the programming language. So the importance of arrays somewhat reduced in the programming. But before the introduction of these data structures like vector or hash table or list, set or map, arrays were the only option to store 100 email IDs, 100 mobile numbers. How do you store 100 email IDs? Simply you declare string email IDs. And because we want to send to 100 students, we want to send some message saying that tomorrow we are having holiday or next week we are having exams. So how do you store all the 100 student email IDs? You declare one simple string array with size of 100. Store all the 100 email IDs in there. Iterate one for loop. Write a SMTP program. Send a mail to each and every email ID. So send 100 emails. So this is how arrays are useful to store multiple variables of same data. And if you want to store homogeneous type of many variables, then you need to opt for a array. But for the array, today the alternative is so many data structures are given, but still some traditional programming and in some unavoidable circumstances we need to use arrays directly in the program. So instead of declaring 10 integer variables like this and initializing each and every variable like this, I1 is equal to 10, I2 is equal to 20, I3 is equal to 30, I10 is equal to 100. Instead of initializing like this, and this is one way. This is another way. Int I1 is equal to 10, comma, int I2 is equal to 20, comma, I3 is equal to 30. And many variables are declared in one row. But even though the number of variable declarations are more here also number of variable declarations are more here. Here what we are doing is we are declaring first and then we are initializing. Here both we are declaring and initializing in one line. But the the length of the line increased to declare more number of variables of same type. So how do you reduce these lines of coding? With the help of array we can do this. So if you want to declare an array, the syntax is unit data type first, and then followed by the array variable name with a square bracket. The square bracket indicates that it is an array variable. If you don't write square bracket, then it will be assumed as a normal variable, a scalar variable, single variable. If we put square bracket, it will be assumed as an array variable. The next new, then you write data type of size. Finish. Data type array variable name with square bracket is equal to new data type of in the square bracket unit size. Here there is one option. Instead of putting square bracket at the end of the array variable name, what you can do is you can put the square bracket at the end of the data type also. So you can put square bracket here or here, but don't put square bracket twice. So it is optional. So you can put square bracket after data type or you can put square bracket after array variables. So fine. This is the syntax. So now coming to the example, if you want to declare 10 integer variables, you can declare like int I square bracket is equal to new int of 10. So 10 integer variables are declared. It can be again declared as int square bracket, and after data type we are putting square bracket. Remember, here after variable name we are putting square bracket is equal to new int of 10. So this is also integer variable declaration. This is also integer variable declaration of size 10. After that, to initialize, anyway we need to write individual lines of code. Here lines of code increases. There is no option. But suppose if you declare integer array with a size of 10, how we can access its element is by writing I square bracket. If you want to access first element of the array, if the array size is 10, then its index starts from 0 to length minus 1 or n minus 1, whatever it is. N minus 1, some people call it as length minus 1, some people call it as n means the last n number. So you can write like 0 to length minus 1, that is the index. Suppose if the array size is 10, the index is 0 to 9. So you write I of 0, the next I of 1, like that, so on up to I of 9 you can access its indexes. And you can initialize value to these variables. So this is called a static array declaration. Okay? First of all, you declare array with whatever amount the size you want, and later on you explicitly initialize each and every of its variable. So such a array variable declaration is called as static array variable declaration. And there is another option of declaring an array is, that is dynamic array declaration. In the dynamic array declaration, both declaration and initialization both will happen in one step. Here we don't mention any size, we'll directly assign value. Int I square bracket is equal to in the floor basis. Remember, wherever you put floor basis, it indicates it contains array of values. In the floor basis, you write 10, 20, 30, 40, and so on. And then you close semicolon, floor basis, and semicolon. So here, based on the number of values we enclose in floor basis with comma separator, the number of values enclosed in floor basis with comma separator, based on the number of values we enclose in flower bases, the size will be automatically determined. If it is 10, 20, 30, 40, 50, 60, up to 100, automatically the size will be declared as 10. Okay. Instead of explicitly specifying the size and initializing the variable separately, in the flower basis, if you directly assign values, array size will be automatically determined based on the number of values assigned to it in the flower basis with the comma separator. So here also variable declaration you can do like this: int I square bracket or int square bracket type. Both are same. Both are same. Initialization remains same. In the flower basis, we need to include all the values. In the flower basis, we need to include all. So in this previous slide, we saw how to declare a static array and dynamic array. Static array declaration and dynamic array declaration we saw. In the next slide, we are going to see how to access those array elements. How to access array elements, system.out.println, and I'm directly printing system.out.println I of 0, I of 1, I of 2. I is a array variable. I is a array variable. I is a array variable. And in the square bracket, we are writing index number 0, 1, 2, 3, 4, 5, 6 up to how much? I of 9 we can write. So 0 to I of 0 to I of 9. Altogether 10 elements can be accessed. But remember, in array there is one problem. If you access array index within its limits, for example, if the array size is 10, its index starts from 0 to 9. So you should access only array indexes up to 0 to 9, but not 10. If you're trying to access index number 10 of array size 10, that means you're trying to access the 11th element. If you're trying to access any element above, beyond its array's maximum index, in Java, we'll get one exception called array index out of bounds exception. Similar exceptions exist in other programming languages also. So, array index out of bounds exception will occur if you're trying to access array index beyond its boundary. Array index out of boundary. Out of boundary means 0 to 9 is boundary. Trying to access index of 10. That means you're trying to access the 11th element. That is, out of the boundary, accessing index out of the boundary. So that causes an index out of bounds exception. So here I'm printing multiple index of values in one line in this statement. Here I'm writing in individual lines. That is the only difference. So if you want to print multiple values in single line, you can write like this. If you want to print separately in separate lines, you can write like this. Fine. If you know the array size, and if you carefully access its array indexes from starting index to ending index, but you must exercise carefully. Based on the array size, you must access the last index of the array. Sometimes we will get array from some other sources where we just want to consume the array, but we don't want to. We are not the one who produce array. Sometimes we get the array from some other sources, like sometimes from the network, or sometimes from the database, or sometimes from the socket, or sometimes from mail somewhere. So we'll get some array of elements. So how do you access them? We don't know its length, how many number of entries exist in the array. Then what you'll do? So in order to access array without knowing its size, without knowing the array size, if you want to access the array, or even though by knowing the size, suppose if the array size is 100, you cannot write I of 0, I of 1, I of 2 like that, I of 2, I of 99, isn't it? So sometimes the array size may be more, sometimes array size may be unknown, but you want to try to retrieve all the elements of the array. Then what you'll do? First of all, what you need to do is, in the array, there is one property exists with the name called length. I dot length. I is an array variable name. I dot length. Length is a property in the integer array. Not only integer array, in the integer variable, length is a property. If you call that this property, it's not a method. Don't write bracket here. It's not a function. It's a property. Length is a property in array. So if you call I dot length, the integer length will be written. The integer length will be written. And in the program, don't write this. Length will be written. After that, what you do? You write one for loop. So from where the array index starts from 0 to up to what? To up to n, to up to which extent? Up to length minus 1. So what you do for int j is equal to 0, Array index starts from 0. J is equal to 0. J is less than length. J is less than length means suppose if the array size is 10, it will return 10. So J is equal to 0. J is less than 10. J is less than 10 means the array will iterate up to 9 times. Index number 9. J plus plus. And here what I am doing, I am writing I of j. So first time I of j 0, next I of j 1, next I of j 2, next I of j 3, till up to it will go up to 9. So this way of trying to retrieve the array index elements by finding out the length and writing the for loop will never cause an array index out of bounds exception. But here there is no problem. Suppose if you mistakenly write j is less than or equal to length again, it is starting from 0 and you are going up to 10. That means you are trying to access 11 elements. In this case also you will get array index out of bounds exception. And then manually while retrieving array indexes also you may get array index out of bounds exception. Even by finding out the length and iterating for loop also you may be getting a chance of getting array index out of bounds exception. And you should not write equal to here. You should write j is less than length but not j is less than or equal to length. So you must exercise carefully these two. And there is another way of accessing the array element, that is for this is called as enhanced for loop or for each loop. This is called as enhanced for loop or for each loop. This is introduced in JDK 1.5 in the year 2005. So in 2005 JDK 1.5 is introduced. So in that year this enhanced for loop or for each loop is introduced. In this enhanced for loop you write for first. Okay, you write I the array variable at right hand side. You just colon symbol, and left hand side you declare single variable int j colon I. Int j, it's a single variable, colon I, it's array variable. If you enclose these two in a for loop, so automatically the array length will be found and each index of value will be automatically populated into j automatically, and loop will automatically determine as much length as the integer variable I is. So here we need not have to find out the length, we need not have to start the array index from 0, we need not have to iterate array index up to length minus 1, you need not have to say j plus plus, you need not have to access array variable with index number I of j, you need not have to do that. Simply you write array variable at right hand side and single variable at left hand side int j colon I. So automatically loop will be, length will be determined, loop will be automatically iterated. Each value from the I will be populated into j. You just simply print j. So among compared with all other ways of accessing array, I feel accessing array with enhanced for loop or for each loop is far simple. So on this probably the next in the next slide I've given a program on that. So what is this? You by seeing this you tell me what is this? Int I square bracket is equal to, in the floor basis we initialize all the values. So what do you call this as? This is called as dynamic array declaration. Am I right? So dynamic array declaration. For it I have 7 index number 7 value, that means 8 value 0 1 2 3 4 5 6 7, sorry 0 1 2 3 4 5 6 7, and 80 will be printed. It will be printed. This is 7, this is 8, this is 9, 0 to 9. And this is if you want to try to access individual element, and this is by finding out the length and iterating for loop. This is enhanced for loop. This is already explained in the previous slide. This is program. This is an example. Now we are coming to the two-dimensional array. Coming to the two-dimensional array, how many number of rows you want in each row, how many number of columns you want. This is what called as two-dimensional array. So you look at this. How many number of rows exist here? 1, 2, 3, 4. 4 rows exist here. How many columns? 1, 2, 3, 4, 5. And this is 4 by 5 matrix. Altogether 20 elements exist. So that means we want to have 4 rows. 4 rows of arrays. 4 rows of arrays. Each row wants to contain 5 elements. 5 elements we want to contain in each row. Like that we want 4 rows. 4, 5, 20. So how to declare this array? Especially while declaring array, not single dimensional array. If you go for a two-dimensional array or three-dimensional array or n-dimensional array, you always keep how the array representation want to be. You prepare one picture. You prepare one picture. You keep one picture in mind, or you prepare one picture of the how the array want to be stored on a paper first, and then you start write a program. But don't blindly start writing a program. So we want like this. So how do you declare two-dimensional array? So this is the problem. So see here four indexes, right? J of 0, J of 1, J of 2, J of 3. This is J of 4. Because of 4, its index starts from 0, 1, 2, 3. And in that each row, how many elements we want? 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 4. 0, 1, 2, 3, 4. That means 5 elements. And if we want int j double square bracket is equal to new j of 4 of 5. 4 by 5 matrix of array. If you declare like this, 4 rows, in each row 5 elements can be stored. That means 20 values can be stored into such an array. Right. Come to the static array declaration. Int j square bracket is equal to new int of 4 of 5. I'm sorry, the previous slide I did something wrong. Okay, I used array variable name. Int j square bracket is equal to new int of 4 of 5. 4 by 5. So here I am accessing. What is the first index of the array? J of 0. J of 0. In J of 0th row, how many columns exist? 5 columns. J of 0, 1, 2, 3, 4. 5 elements. Again, J of 1 of 0, 1, 2, 3, 4. The next again, J of 2, 0, 1, 2, 3, 4. Again, J of 3, 0, 1, 2, 3, 4. So altogether, how many rows? 1, 2, 1 row, second row, third row, fourth row. In each row, how many values we are having? We are having 5 values. 5 values. Altogether, 20 values are assigned. And here, array variable declaration took 1 line, but initialization took almost 20 lines of code length. Anyway, but it is unavoidable. If you want to declare an initialize array, you have to do like this. Otherwise, you go for a dynamic array declaration. So, anyway, fine. First of all, we'll see how to access this array. So, how to iterate this array? So, what you do is, first of all, you write int counter is equal to 0. Why we declare counter variable, that we'll see later. This is dynamic array initialization. The one way of array initialization is declare array like this. Initialize array elements by accessing each and every index. This is one way of array initialization. Another way of array initialization is, what you do is, you iterate one for loop. For k is equal to 0, k is less than 4. So how many times the loop will be iterated? 0, 1, 2, 3. Less than 4. 0, 1, 2, 3. At 4 times this loop will be iterated. Outer loop. Inside, we are iterating one more for loop. For L is equal to 0, L is less than 5. 0, 1, 2, 3, 4. 5 times the inner loop will be iterated. And for each iteration of outer for loop, inner for loop will be iterated for 5 times. So each time what I am doing, I am incrementing, I am post incrementing counter variable. Counter variable initially 0. Counter plus plus. If you use counter plus plus is a post increment. Post increment means the value will be used and after that the value will be incremented. So during the first iteration, the counter variable value 0, that will be assigned to k of 0 of 0. J of 0 of 0. To that 0 value will be assigned. Again to the j of 0 of 1, value 1 will be assigned. Like that it will keep on go. So for 4 iterations of outer for loop, inner for loop will be iterated for 5 times. So this is one way of dynamically this is not dynamic array initialization. Dynamic okay, you can call it as dynamic array initialization, but array declaration separately, dynamically array initialization. In the previous case, array declaration, static array declaration, and static variable initialization. Here, static array declaration, dynamic array values initialization. So, after completion of that, so you find out the length, find length of the j dot length. Initially 4 will be written. So outer loop will be iterated for 4 times. Int k is equal to 0, k is less than j dot length, k plus plus. So first j dot length means the outer length will be returned and the 4 will be returned. After that, during the iteration, j of k means j of 0 initially, the next j of 1, the next j of 2, then j of 3. Each row we are accessing here. Each row we are accessing. Again, dot length if you find out, this will return 5. So here if you write j of k of m, so initially j of k is 0 and m is 0, the next 0, 1, 0, 2, 0, 3, the next 0, 4. The next start 1 of 0, 1 of 1, 1 of 2, 1 of 3, 1 of 4. The next 2 of 0, 2 of 1, 2 of 3, 2, 2 of 3, 2 of 4. Again 3 of 0, 3 of 1, 3 of 2, 3 of 3, 3 of 4. Like that, the values will be retrieved based on the number of rows and columns. So, array, two-dimensional array, this is static array declaration, static value initialization, this is dynamic value initialization, this is retrieving elements from the array using length syntax. Here it is completely a two-dimensional dynamic array declaration and initialization. Int j square bracket is equal to, we want how many rows? 3 rows. In each row how many values we want, or otherwise we want 3 rows. In each row we want 4 values, or otherwise we want 4 rows. In each row we want 5 values. So however you want. So you open one flower basis. How many rows you want? You want 3 rows. 1, 2, 3 rows. In each row, how many values you want? You want 4 values. 1, 2, 3, 4. 5, 6, 7, 8. 9, 10, 11, 12. So how many values? 3, 4 are 12. 3 rows. 3 rows. In each row, we are having 4 values. 3, 4 are 12. So on the entire two-dimensional array variable declaration and initialization completed in a single line. Instead of writing this much of code of declaring array and initializing array, it happened in a simple single one line. Even we can declare a 4x5 initialization also, 4x5 row initialization also. Here also we did the same thing. One is using finding the length and accessing using its indexes. This is one way. And another way is enhanced for loop. In enhanced for loop, you can see like this. For int n square bracket column j. J is a two-dimensional array. If you write j as an array here, in its each iteration, it will return its internal array. And for 4 rows, each row contains 5 columns. And in the first iteration, 5 column array will be written here. In the second iteration, 5 column array. In the third iteration, 5 column array. In the fourth iteration, 5 column array will be written here. And this j iterates for 3 times. In its each iteration, it will return 4 size of array to this variable that we have taken into int n. So again, we are writing for int o colon n. This loop will be iterated for 4 times. Each value will be assigned to OBRPD. So compared with finding the length and iterating over the array with their indexes, the enhanced for loop is much easier in writing the program. So this is two-dimensional array. And here is an example on three-dimensional array. In this three-dimensional array, how many rows we are having? 1, 2, and 3. In each row, how many values we are having? Columns we are having 1, 2, 3, 4. 4 columns we are having. In each column, how many rows we are having? 1, 2, 3, 4, 5 rows. And 3 into 4 into 5. 3 4s are 12. 12 5 is 60. 60 elements altogether. 3 rows. In each row, we want 4 columns. In each column, again, we want 5 values. So this is the array declaration See, I have zeroth element contains I have zeroth column. In that I have zeroth row, zeroth column. In zeroth row number 1, 2, 3, 4. Again, in I have zeroth row, I have 1th column. I have zeroth row, 1, 2, 3, 4. Again, in I have zeroth second column, I have 0, 1, 2, 3, 4. Again, I have zeroth third column, 0, 1, 2, 3, 4. Elements we are having. Similarly, I have 1, 0. I have 1 of 0. Again, here you want to have 5 values. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this represents row. This represents each of its column. Each of its column. Each of its column. This will represent the major row. Here it is 0. Here it is 1. Here it is 2. Here it is 0th column, 0th column, 0th column, 1, 1, 1, 2, 2, 2, 3, 3, 3. In each column, again we want 5 values. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is how we want to organize 60 elements in a 3 by 4 by 5 dimensional array. So you can imagine how, I don't say difficult, but how much concentration we need to declare such a array variable declaration and then later initialization. So here are the values. But if you really store the values, you store values like this. 3 rows. In each row, you want 4 columns. In each column, you want 5 rows. 3 rows, 4 columns, 5 rows. This is 2 by 3, 2 by 3 by 4. And this is another array. 2 rows. In each row, we are having 3 columns. In each column, we are having 4 rows of values. 24 values. So this is 2 by 3 by 4 rows. 2 rows, 3 columns. In each column we are having 4 values. Like this, 2 rows. In each row we are having 1, 2, 3 columns. In each column we are having 1, 2, 3, 4 rows. Okay. So altogether 24 values. And first of all, we want to see how to declare such a 3-dimensional array, then initialize values into array, then accessing the array elements. See here, in IARE, here we need to use 3 square brackets: row, column, row. Int IARE of is equal to new int of 2 of 3 of and 2 by 3 by 4. Matrix array we want to declare. In that we want to store the values. So here is the array declaration. First of all, which row we want to access? 0th row we want to access. In that 0th row, how many columns you are having? 3 columns you are having. 0th row, 0th column number 1, column number 2, 0th row, the 0th row only, the 0th row only, the 0th row only. This is the 0th column, this is first column, this is the second column. In that 0th column, again we are having 4 values, 0, 1, 2, 3. In the first column, 0, 1, 2, 3. In the second column, 0, 1, 2, 3. Altogether 12 values are initialized here. 12 values are initialized here. What is 24? One more set of. And again, row number 1, 0th column, first column, second column. 0th row, 1, 2, 3. 0, 1, 2, 3, 0, 1, 2, 3. Altogether 24 values are assigned. So, how to access such an array? First of all, we need to find out the length of 0. 2 times this loop will iterate. Again, I is the array, integer array. I of j, that means it's a 3 columns. That length will be written. And a 3 column length. 3 times this loop will iterate. This loop will iterate length through. Again, I of j of k, in that each column, again if you find out the length, there are 5 rows. Again, 2 by 3 by 7, 4 rows again. Again, the length will be written as 4. 4 times this loop will be iterated. 3 times this loop will be iterated. 2 times this loop will be iterated. Altogether, all the values are printed here. So finally, we are writing I of j of k of m to display its value. This is what you call enhanced for loop. This is by using length and for loop with indexes. This is enhanced for loop. I, we have written it right hand side. Left hand side, what it will return from the I, it will return 2-dimensional array because it's a 3-dimensional array. I, if you write it right hand side, one 2-dimensional array will be written here. From that, again 2-dimensional array, if you iterate, again single dimensional array will be written here. Again that single dimensional array, if you give, each and every scalar element will come. You simply print the value. And compared with the previous array, see how simple enhanced for loop is. And first of all, if you write a 3-dimensional array here at right hand side, 2-dimensional array will be written. If you write 2-dimensional array variable here, single dimensional array will be written here. If you write single dimensional array here, scalar, each and every scalar value will be written here. And that value we are printing. Compared with the previous example, this example reduces a lot of coding. And a lot of error proneness also. Because here, if you improperly access any array index, you will get array index out of an exception. Here you want that. You won't get that. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.